Okay, so first of all, before I begin with the talk, I have this slide called Chekhov's slide. Quick question to you. If I say correctness, what's your emotional response? Oh, thank you. This is why you're in this room. Um, so here am I. Hi, I'm Florian. I'm managing director of a company called Ferrous Systems. I was previously part of Rust project leadership. Particularly, I was part of the Rust community team and later of the core team, and I'm one of the co-founders of the Rust Foundation, so the initial setup team out of the project that actually set up the foundation. I've also run a few conferences. There's a list on it, particularly RustFest and also RustFest Paris over here. And RustFest had always had the goal, it moves around Europe so that the places where we were have people that can then organize local conferences. So this conference is very much success for me. So big applause to the organizers, please. And it was admitted very much on stage this morning that Guillaume convinced those people to run it. And Guillaume loved the room, luckily, because there's the saying between conference organizers that friends don't let friends run conferences. He shouldn't do that. Okay, what does Ferrous Systems do? We've been founded in 2018. I've been training Rust since 2015. We joke that we have more than 100 years of collective Rust experience. Particularly, currently, we're bringing Rust into safety critical by qualifying the compiler for these levels and fulfill a number of crucial roles in the Rust environment. Particularly, we implement and maintain Rust Analyzer and a couple of other tools, particularly for embedded systems and our own compiler distribution, Ferrous, that is both useful and safety critical, and also because of the EU now wants you to use supported tool chains through the Cyber Resilience Act. And yeah, enough about that. I have this question, like now having been more than 10 years around the community, which is, why is Rust successful? Like seriously, why is Rust successful? Because programming languages being successful is a pretty rare thing. Inventing programming languages is surprisingly cheap. You can do that over a weekend. There's books for that. You can have a lot of fun. There's a person that runs a database about programming languages, and we literally know of more than 9,000 of them. This is more than human languages on this planet. The programming languages get invented every weekend. So the game is really stacked against new programming languages in reverse, and that's actually quite interesting. Little success is already pretty big success. So languages that come across a certain threshold to survive for 1 or 2 years and are around are already quite successful. So if you're in discussions with, for example, people doing Mosaic or something like that, they're already pretty big. You just might not feel it yet. And there's a couple of interesting things here. Why did we get Rust in the 90s? And this is an interesting paper I found recently. It's from 1995, and it's called Towards Alias Free Pointers, which, if you know a little bit about Rust references and how they work, one of the biggest statements of Rust references is that they never alias mutably. And this paper lays out such a system quite clearly. The other thing is, such a system is actually pretty cheap to check, and the Rust compiler proves that. No one bothered. Like, that paper was rediscovered at some point. So we could have had Rust in 1995. Maybe not Rust as is, there's certainly some innovation, but like the basic thoughts are old, very, very old, especially in terms of computer sciences. So the first question I think that we need there is, like, do we have a problem? And one thing I also want to say to prefix that, just to be clear of what I'm saying, programming language adoption is a research field. We don't quite know where it goes and how it goes. But I think one big mistake we make is we often look at programming languages under a microscope. Like, here's the tiny feature there, here's the tiny feature there, Rust has references here, another language has pointers there, things like that. When it comes to programming language adoption, the one thing that I've learned, or what's my opinion, is if you're looking at a programming language that's an incremental step across from one that currently exists, it'll fail. Like, one of the big complaints about Rust is that it's a huge step out from what people are used to. And I think that is part of its success. Because if we were talking about this is 5% better, I could also just buy a tool. Because when we're talking about use a new programming language, the thing that we need to be aware of that we're literally asking people to bring down at least one of their houses on their street and rebuild it anew. It's like we do this regularly. We raise down houses and rebuild them, and there's good reasons for that. But there's also good reasons for keeping them around. The other thing is programming language adoption is hard. And there's a big problem for people that develop and are interested in new programming languages, which is they have built a certain skill, which is learning new programming languages. While it's actually true that learning a new programming language for people who don't do this like every couple of months is actually a hard thing to do. The problem here is that the first language you learn a certain way of how things should work. The next language you learn has different approaches, and that leads to a certain time where your old knowledge struggles with the new. That's the bad news. The good news is the conclusion of this paper is learning languages is the same as learning anything else. This is a described effect, and this is why we have teachers. Like teachers are literally, and trainers are your way through working through this problem of telling you, please forget your old, take a new thing, and this is why it's like that. That is the process. So the good thing is that is a thing that we've learned for thousands of years and how that works. We're getting better at it, but it's something that's tried and true. So programming languages also aren't that special, but please never go to someone and say learning a new programming language is easy if you're one of the people who does that regularly and who's a programming language nerd. The other thing that I found interesting about Rust, and that contributes to its success, is its willingness to question beliefs. This is actually the very first slide that I've seen from a Rust talk that I've seen by Alex Crichton in 2014. You may see the age because the resolution is so low. So it was, and that was a very clear belief, the idea that there is a continuum. A language either gives you control or it gives you safety, and you're somehow across that line. And Alex, back then being one of the people who were designing the language, said, how about, can we just put something up here? Is that possible? Can we have a long language with high control, but also with high safety? Like, that was a radical notion back then. But also, it's also important to have beliefs on where the world is going, like we need to question beliefs. And I'll reassemble that a little in a second. There was a very interesting talk at Conf 2007, where there was a question from the audience to Walter Bright, also one of the designers of the language, who was pushing for making D completely memory safe. There was a question whether that wasn't too radical. And he postulated back then that the problem of memory safety is already here. It is a problem present in all programs, but there's not the effect yet. And what he postulated also was memory safety will become a tool requirement. And the third thing was the pressure will not come out of the community. I have an issue with the way he uses the term the community because that meant us programmers. What he was referring to the outside was regulatory bodies. They're also a community, and I think it's important to model them as that. And if you're looking at all the news that we have over the last few years now, CISA making statements, move away from C and C++, move towards memory-safe programming languages. It has a moniker now. It's called safety by default and security by default. There's a whole regulatory push towards making sure that everyone needs a memory safety story. My last addition to that, just last week, I spoke to a startup that said one of my investors asked me about the memory safety story that my startup has. This is a weird feeling as someone who's been around hacking communities for 20 years that suddenly, like a very, very technical thing like memory safety has transcended to being something that's discussed in the US Senate and the EU Commission. And that's actually good if you're a programming language that puts memory safety front and center. Last bit here. And this is a really interesting paper, Empirical Analysis of Programming Language Adoption. That's interesting and may hurt a little. The important claims of this paper are: programming language adoption is a social process. The emotion towards a feature is more important than the rational view. Hence the question. The other thing is, popularity is actually a big decision-making factor in people adopting new technologies. So if someone here is more on the management side of things, popularity is it's actually okay to decide by popularity. The important thing, though, is popularity comes in two flavors: breadth and niche. There's things that are super popular because they're super fitting a very narrow niche. There's few people practicing it, but it fits like a glove. Rust is breadth adoption. But for example, if you look at languages like Erlang, like a lot of the core networking services for Call of Duty are written in Erlang. It's probably about 10 programmers, but it just fits the problem really, really well. The whole rest of the organization is C, C++. So an interesting thing they ask for is, do features lead to success? And the hard answer is no. So if you find yourself in a debate of this language was adopted because it has static typing and this one isn't, well, just step out. It's actually not that relevant. However, there is a little bit of a correlation, and particularly the question is, what do people value? So the question they polled was less, do you think this feature is better or worse, but do you value that feature or not? And then the question becomes interesting. And particularly when this study was done in 2013, static typing and correctness were not in the value set of the respondent group at all. So basically the answer was, no, we have different problems and we care about different things. We don't care about correct programs at all. So if you as a reminder, 2013 was the time where hyperscalers came up, Ruby, Python, especially JavaScript, Docker, and Kubernetes were all there. Like the question was scale. This was literally a mindset of if it crashes, we can bring it up again, it's fine. But there's an interesting thing in that paper, and that's what I want to use as a jumping pad. We found that developers generally value expressiveness and speed of development over language-enforced correctness. But the second part is interesting. If you look at the organizations and the situations those programmers are in, correctness becomes a more influential factor, while simplicity, platforms, and development speed matter less for large companies. So the larger the project and the development environment gets, suddenly this gets more important. Again, state of 2013. So we are now 12 years later. I've got a question. Who knows this? Move fast and break things. Who was that? Zuckerberg, Facebook. Move fast and stable infrastructure. Who knows this? Who's that? This is actually the current development motto of Facebook since 2014, which is never trust social media. Everyone throws move fast and break things around, while this is the actual motto. And there's an interview. I'm not the biggest fan of quoting Zuckerberg, but there's an interview where he reasons that like our system got too big, like we can't do move fast and break things anymore. So right after this study, there's an inflection point where at least one major player decided, okay, that approach doesn't work anymore, which also reflects that thing that was found in the study about the larger the organization gets, the more that becomes a problem. So if you look at today, Ruby has a type system, Python has a type system, JavaScript has a whole language that has type in the name, Swift is the other big player in the market, OCaml is becoming popular again as a productive programming language. They have a community team now. I'm very happy about that. They're in good touch. So, yeah. And this is precisely the problem that Rust addresses. Again, look at the timing, 2014, Rust on 1.0 is 2015. So Mozilla Research found at the beginning of that project, they have a complexity problem with one of the largest code bases on Earth. About 20 million lines of code of C and C++. becomes really hard to tackle, leading to crashes and security bugs. And particularly, bugs are often not introduced locally. It's not the problem that coders don't have their function in their head. The problem is they don't know what they're interfering with on the other side, and the crashes come from that, particularly during evolution. And while solutions existed, they come with a runtime footprint that you can't pay on such a large code base, particularly garbage collectors and runtime detection of concurrency errors. And research solutions have been out there since the, since the 90s that could tackle these problems. Again, why were those research solutions not picked up? Because no one cared. No one had a positive emotion towards them. They had other problems. And Rust addresses this. Rust is memory safe. I'm preaching to the choir here, even across code modules and interactions very easily. It keeps, particularly through the borrow checker. And if you look at Rust code again tomorrow or some other point, I hope you have a weekend, all memory reasoning is mostly local in Rust. Like you look at your function and there's not a lot that's out there. And the borrow checker is actually a language that allows you to observe what the memory relationships are outside of a function. It has no garbage collector. Yeah, that addresses the garbage collector problem. And it values correctness by default. Safe language, safe Rust is the default. Unsafe Rust is something you need to opt in. So, and from that perspective, in 2025, if we're now looking at who's using Rust, it's being used in all major operating systems, mostly nowadays. I guess we can just admit success and call it quits. Rust is a mature, accepted language within many organizations that can be chosen without any deliberation. This is a pretty big statement to do after 10 years, and I think it's a useful one to actually internalize that we are at that state. Because from my experience of being also part of the leadership of the Rust project, it is actually something you need to admit at some point, because that means you suddenly need to work differently. I've been, to be quite clear, there have been people who have left the Rust project when it became 1.0, because it was their playing ground, their experimental field. They were like, okay, now this is stable. No, I won't do this anymore. There's a very good talk at RustFest about that. That's called The Rust That Could Have Been, by one of the project members, very productive project manager member who left because he couldn't have a playground anymore, which is completely fine. It's not a complaint. It's just not that state anymore. And I think that also means we are currently at an inflection point where Rust is an accepted industry language. And that begs the question, well, continue as is, and second, are the challenges that we address still the challenges to address? In a way, yes. In a way, no. But one of the biggest things I'd like to state bluntly is we should stop talking about the memory safety problem. It is now expected that memory safety is something to be addressed. So Rust is memory safe is becoming a checkbox and not a distinguishing element. Particularly if you look at large adopters of Rust, Google, AWS, Microsoft, Meta, all of them are already using memory safe languages everywhere else. They are big Java shops. Microsoft has C#. The only thing that Rust still has a differentiator as is it has that checkbox, but it has the other properties of it still has high control, particularly over memory. Memory burns power, and power savings currently are a huge issue, particularly at hyperscalers. The language is built for large-scale assembly of large programs. It is literally a design goal. So huge software, energy efficient, is a much more of a driving factor than the memory safety moniker. So if you're trying to sell to your boss, memory safety is not the thing anymore. And I would like to identify two modern-day software challenges that if you go to conferences, for example, in the automotive industry or in other places where large complex systems are being built, running around. And the two things are, first of all, correctness at large. We build larger and larger programs just casually. So software is being written at an unprecedented scale, both in how it connects to other systems, and second, how big the programs by themselves are. And integration of those large systems needs far higher quality. If you ever talk to someone who implements a TCP stack, half of the TCP stack is the implementation of TCP, and the other half is the implementation of everyone else's bugs. And if we can reduce the number of bugs at those points, we will have much easier assembly of distributed systems. And the second is correctness in motion. Software is frequently updated, needs to be frequently updated, and often nowadays component-wise. There's a CAVE found in this library, I need to update this. There's a issue in my macOS, I need to update. People still expect the applications to run. This is literally a thing. I heard a very good talk by Apple about this, that it is now something that a consumer expects. A consumer expects the interface between your operating system and your applications to not break. They don't voice it like that, but that basically means I can use my app in iOS 14, in iOS 19. And so there's a much higher expectancy on how often we can break our APIs. And we need to be migrated. So applications are getting migrated across those foundations quite frequently. Portability becomes a big issue, and Rust is very strong at portability. So we're in a good position, is what I'm saying. The biggest problem is let's not get complacent. And luckily we're not. So the Rust project has actually stepped up. They're now for every quarter, or I think currently it's for every half year, setting a goal. Like teams set their goals, and you can look at the goals list and where it's going. It's a pretty new thing. And because it's a pretty new thing, it's working okay. It will probably work better in 2 years. It's the first step. That's good. And we're addressing some of those needs. And this is also a point where we'll call it into the room on. These could also be points where you can be part of if you want to. So the first one is Rust is getting a specification. There's an RFC out for that. And one of the things I often hear is, well, specifications, they're a lot of work. Do we really need them? I think the thing that people don't understand about programming language specifications, Rust has an RFC process. We heard a talk about that. The problem is Rust now has hundreds of RFCs. The state of what's valid Rust is actually, I need to read all 100 of RFCs, need to find the cross connections where they contradict each other and figure out what's real. Specification is basically, let's take hundreds of documents, fold them into one. You can engage in that. The Rust specification team is interested, and it's actually good work that you can do on the side, because the nice thing about programming language specifications is you basically need to write a sentence and then figure out if it's true. And that is something that can actually be done like 10 minutes, 15 minutes at a time, playing around with the code. Like I know people who have literally learned Rust by writing a Rust specification, just by playing around with a playground and figuring out if that's actually true what they wrote. So this is, people often think this is very high bar. It's actually pretty low bar. There are high bar parts in writing a specification, but statement by statement, they're actually pretty simple. If they're not simple, they're also not good. And the other thing is, well, let's make Rust the most correct ecosystem. Here, there's still a lot of things to do, and I use this slide more as highlighting that, luckily for me, just a couple of days ago, Nico Matsakis has set out the plan for let's make Rust a very good foundation, a programming language for writing foundational software. So something that other software relies on and can rely on. The other thing that I want to advertise for is coding standards. It's been a long complaint, actually, of my side that Rust actually doesn't have a coding standard. I think it's an effect because Rust leans itself pretty heavily towards an accepted coding style that a lot of people learn rather correctly through cultural osmosis. Why not write that down? Why not write the reasoning behind that down? Because sometimes the reasoning is actually quite interesting. There's ongoing efforts for that in something called the Safety Working Group, which deals around functional safety, Rust on cars, Rust on planes. And you may have heard that C, for example, has a standard called MISRA C, which is a safer subset that takes a little bit of the teeth out of the language. I'm not a huge fan of that. Given that Rust already has the goal of being a safe programming language, if there's any kind of coding patterns that are found that could not be used on a plane, that should also not be used in a data center. So we're actually pretty narrow there and pretty close in values. So given that no coding standard for Rust exists, I think that should be the coding standard. I think a coding standard should exist. It should just then be a safety coding standard. So Pete, who runs this, is very much behind this message, just to be clear. This is also a pretty easy thing to contribute to, because one of the things that the Rust project does marvelously is, if you want to look for good Rust style, read the core and the standard library. They're making sure that that stylistically Rust is often very correct, or the Rust fundamental libraries are often very correct, to the point where they're migrating them over to new style completely if a new style emerges, and that makes it very easy to contribute. And I'm happy for the moment where you can actually look at a document and look at the reasoning why things are like they are. And as an extension to that, and this is where I think it actually becomes a bit dangerous, is we have also not written down how you to properly write unsafe code. There's a thing called the Unsafe Coding Guidelines. They're not very complete. And the very same working group, the safety working group, has set out to finally write the document on how to write and review unsafe code, which things are safe to do, which things are clearly out, which ones are still under discussion, and how to deal with that. Same argument. If you're talking about foundational software, I talked about the problem of dependency breakage. There's a very good project around that. Particularly, Simver is very hard. Breakages are common, but most of them are accidental. There's a good blog post by Pragmatic where he analyzes the problem, and he says about 3% of all libraries under inspection did accidental Simver breakages. That sounds very little, but because you build dependency trees, that problem statistically becomes much bigger than that sounds. And because Rust leans towards micro libraries and very small libraries, we have an accelerated problem. So if you want to deal with that problem, and if you are writing a crate, cargo Simver checks, really run it. It's a really good tool that checks your old library against a new library and tells you if you broke your API. This is a thing that was called, I know two authors of predecessors, and this was called impossible to achieve, and cargo Simver checks is the library that just achieves it. It's a really big thing, and it is surprisingly easy to contribute to, because it has a query language where you can go to the issue tracker and just write a query for a problem that was identified. Usually takes about half an hour or an hour. So this is a really good. So first contribution is, if you're publishing a library, run it. Second contribution is, if you're not publishing a library and you're interested in what interesting Simver breakages Rust has, contribute there. Second thing about dependencies, and this is a thing I'll probably be on stage for the next 10 years, because I have been on stage for this for the first 10 years of Rust. 1.0 is a good version. It is really okay to release a library at some point as a 1.0 and pretty early, instead of staying in that 0.1, I'm breaking all the time space. You always got the option to go to a 2.0 version, and that will be easier, and that means that Cargo's dependency resolver will pin people to the 1.0 version until they properly migrate. That's the mechanism that we have there, while we are in an ecosystem where people just don't care and Cargo just updates the dependencies all the time. So this is also why we started an initiative to actually upgrade everything that we have within Ferrous Systems to 1.0 and finally stabilize it, because I can't be on stage preaching while not doing that ourselves. The second thing about dependencies, I'll make it short here because I'm running a little bit out of time. Cargo really is trying to become more sophisticated in handling dependencies, particularly operating system dependencies and C code dependencies. Ed is here at this conference, if that's an interesting problem to you. please be in touch. This is not necessarily hard work, also as an information on how long these things, but the problem with cargo is cargo impacts literally the whole ecosystem. So it means it, it, every plan needs to be checked in every corner and deployed against all the patterns that are out there. So because it has such a wide community impact, it may at some point be very slow. And in the end, still, Rust needs to polish around some corners. I'm a little bit unhappy that we made it now into a decade without stabilizing our memory allocation APIs. And I think like some of these things should finally be moved out. This is more a moral statement, or we should decide that what currently exists is okay and just keep it into perpetuity. I see someone who's like, no, we shouldn't keep the current memory allocation API. I'm with you there. But that also doesn't mean we can still speculate. There's currently a very, very interesting push to actually enable a small contracts language in Rust using attributes and functions. It's called core contracts. It's recently been merged. It's obviously an unstable feature, which, if successful, would actually make Rust the first broadly deployed language with an in-language contract language. I know that Spark exists, but Spark is not broadly deployed. I find that an incredibly interesting extension, but just to be honest, that's still a few years out. That means we shouldn't stop on the other problems. Yep, so back to the beginning. The first thing we should ask ourselves at all times when investigating or when being in a community and thinking about what to do is, even if we're there for a long time or just for a time, is asking ourselves, do we have a problem? I think that's a problem that a lot of communities have. Not enough self-criticism and not enough willingness to say this sore spot is actually a sore spot, and ask that question very broadly and also with all users of Rust in scope. And if you find one of them, collaborate and go to places where we usually don't go, like things like, could we have a contract language? Could we investigate that? Surprisingly often, sometimes the answer is also no. This is actually working well, which also gives quite some confidence. So that question is useful in any case as a software engineer. This is what I want to leave you with. Thank you very much.